everyone, and welcome to the Cisco Community Live event on Tenant Routed Multicast in VXLAN EVPN Fabric. My name is Hilda Arteaga, and I am a community manager of the Cisco Community and the host of today's event. So before we start, I would like to let you know something about the community. And actually, the Cisco Community is not only one of the biggest communities that Cisco has, it's also an online forum with over 500,000 members. Actually, we are almost reaching 1 million, where you can get answers to your technical questions prior to opening cases with a tag. Also, you can create or answer to other people's questions or contribute with documents, videos, and blog, and also rate this content to make it valuable for others and for yourself. Before we start, I would like to share with you some couple of news and events and activities that we have on the Cisco community that can be of your interest. So first of all, we have an Ask Me Anything following up this event. That is that we have a forum event connected to this webinar. And the way it works out is very easy. Actually, you have any question, maybe after this session concludes, because this is a live session, you can go and post that in that forum till Friday, May 29th. And Alex will be helping out to cover this question. Also, let's say that, I don't know, maybe 1 hour after this event or 2 days, you think about something that Alex just mentioned, and you have the question, you just can go and post it there. And also, if there's a question that we are not able to cover during this live session, either because there are too many questions or perhaps because we need to validate information, we're going to place it in that Ask Me Anything event, and you will find the answers there. So all the information that I'm mentioning to you, you can find it on the chat panel, which is allocated on your right side of your screen, or if you're on a mobile device, on the 3 circles that you can see on your screen. Also, would like to invite you to participate in this special event. As you might know, Cisco is doing a lot of effort due to COVID-19, and it's providing a lot of technology like free WebEx, like free security solutions like AnyConnect, Duo, Umbrella, and also it's helping out people to get connected. So we are talking about wireless technology, like the Catalyst. We are talking also about like Aeronet, Aeros, and also Meraki. So if you have questions about any of these offers that Cisco is providing, or how you can enable that and connect your micro or your enterprise, your business, then you can go to this forum event and make questions. We have been helping out people in other technologies, so please take this opportunity. It's for free, and all of you can access to this one and can get your questions solved from sales to implementation to deployment and configuration as well. And also, we would like to invite you to become an event top contributor or someone who actually engages in the community. We do like to recognize the people who are doing great there and also helping us to capacitate others and provide them information. And one of the ways to do that is actually by rating content. Please help us out to identify and mark all that content that you find valuable. The way to do it is very easy. You can see a tiny star like that, the one that you can see on the screen, just right there, and it will give a helpful vote. That means that you are telling that person, hey, this helped me out to solve all these questions. Or you can see the accepted solution as well. So let's say this answer solved my problem. So in future, when someone else is looking for information, they can say, hey, that one is marked as a solution, so this is going to help me out to solve my problem. And not only that, that helps us out to encourage and acknowledge people who is actually contributing in the community, so then they can become a top contributor. Let's get started because there's a lot of information here, and I would like to introduce you to our presenter. His name is Aleksandr Blusenkov, and he's a technical consulting engineer for the Cisco's CX Center on the data center team in Europe. He has over 13 years of experience in the IT industry and a vast knowledge of the Nexus portfolio of products and the integration with their environment. He joined Cisco in May 2011, and he has also experience in developing trainings focused on platforms and solutions and troubleshooting. Alex holds a master's degree in telecommunications and 2 CCIAs, one in enterprise infrastructure and the other one in data center certification. So welcome, Alex, to this event, and thank you so much for joining today. All right, so next in file, we have 2 experts that will be helping us as question managers. That means that they will be helping out to cover all your questions in the meantime that Alex is presenter. So please don't feel shy and ask your question because there's someone who's going to help you out to take over it. So I will start with Nikolai. Nikolai is a technical support engineer in the Customer Experience Center as well. He has many years of experience supporting switches and data center technologies, and he holds a CCIA as well. Then we have Aleksandr Blusenkov, and he's a technical consulting engineer of the Data Center Enterprise team and a Customer Experience team. He worked in the Data Center Enterprise team for 8 years, and he specializes in the Nexus platforms, in the different ones, and all the solutions built for these platforms, such as Virtual Point Channel, VXLAN, among many others. He holds a master's degree in computer science and actually two CCIAs as well, one in enterprise and the other one in data center. So thank you so much, Nikolai and Aleksandr. I have to tell you guys, they are kind of like a dream team in Europe, so we are very lucky to have them today, and I hope you learn a lot from them. And well, also for those who would like to have a deeper look into everything that Alex is going to cover in today's presentation, you can double check it out in the community. You will find the link on the chat. It's already available, so you can see more details there just in case, all right? Just to start to conclude here, don't forget that you can submit your questions at any time. We have people helping out here. We have Nikolai and we have Aleksandr, so please don't feel shy. We will be there for you. The only thing that we would like to request and ask you, please, is please post them out or try to post them out on the Q&A panel. It's located on the right side or at the bottom. That helps us out to manage the questions easier than on the chat. And please use the chat for any other kind of inquiries, like you're having logistic issues, your audio is not working properly, or you would like to contact any of us, all right? So thank you very much. And what I will do right now is I'm going to pass the microphone and the present as well to Alex. So welcome, Alex, and thank you so much.
Thank you so very much, Hilde, for such a nice and warm welcome. I really appreciate that. And believe me, if you ask me to do the same, I won't be able. You did perfect and great job. Thank you so very much, everyone who joined this session. We know that, for some of you, it's early morning or noon or probably evening. Anyway, I really hope that you will be enjoying it, no matter what is time for you right now. So you probably know the reason why you're here. You're here for TRM, or so-called Tenant Routed Multicast. This is one of sort of solution which we came up with, multicast for VXLAN. And the goal of this session pretty much to make you familiar with what exactly we have underneath, what exactly we are using there, and how the overall evolution of the multicast was happening within the VXLAN. This session, though, implies, or, well, we assume that you know at least some basic knowledge related to the VXLAN. That would definitely help to understand more from this topic. Our agenda will look following way. We cover here quite some basics related to the multicast itself, just to be sure that everyone is on page and we're in sync. And then we'll jump to the concept of traditional forwarding within the VXLAN, cover then a couple of functional components, and then we're going to look more closely into the portfolio of the different solutions. Here we talk about the RPLS and external RP. The last one, but not least one, and I think one of the most important, is the TRM implementation within the multi-site. This is something where we have quite a lot of developments ongoing right now, and I believe you may one day enjoy what you see right now. Well, actually, in a couple of minutes. But before we move forward, there will be one sort of question where we want to, make sure that you're still with us, you're actively participating, and well, it's here. What is your experience with VXLAN? So as you can see, there are a couple of options available. You do have a couple of minutes to answer that, and Hilde, correct me if I'm saying wrong, but this should be appearing in the polling screen or the polling window. Yeah, I can see them as well, and we have we have quite some good rate. I really like it. So yeah, some guys are having quite good experiences, I can see here. Nevertheless, whatever your level is right now, I do really hope you will be enjoying it, and I do hope that you will get something quite useful. We're jumping in, and we're starting, as I promised, with IP basic concepts. So what is all about IP multicast? Well, there will be something we call multicast distribution tree, and that's a way how we are making unicast forwarding slightly better than it was before. What I mean by saying that is, well, very simple. Whenever it comes to the replication, no matter who does that replication, it means that the source of the traffic is responsible for generating multiple flows. In reality, it brings some benefits, like traffic can be different of kind. It's a UDP or TCP. You can have a sort of controllability on that. But on the other side, that replication brings some negative effects for the network environment. This being said, we, as you know, many years ago, we came up with the multicast solution, and that's pretty much where all replication was delegated to the networking devices. So that's the gears which are responsible right now for doing this job. And there are a couple of things to remind you about. The one of them is the multicast uses specially dedicated address range. That's pretty much starting with 224/4. And, well, for now, that's pretty much all what you need to know. This being said, by the way, multicast routing implies or relies really on the separate or dedicated routing table. If you never used before multicast, then it's going to be something better to know. Apart from regular show IP route command, there will be show IPM route, and that's the place where you can basically start any sort of troubleshooting or any sort of investigation in your network. Do that, and you'll see there at least one of the following. You will see entry called star comma G, or the source, or S comma G, if you like. S comma G stands for the source dash group. And as you can see on this particular screen over here, we talk about the source of the multicast, which is 192.110.55, which is streaming to the group 239.111. Talking about the multicast distribution tree, there are two already classical schemes available, and the one we called shared tree, and that's nothing but just a scenario when each and every source, potential source, can stream within the group. Well, that sounds good, but that also means one important thing. There should be some particular point in the network where all streams are, meeting together. And that's so-called rendezvous point. Rendezvous point, that's the place where everything starts. When source, like in this case, S1 and S2 are streaming traffic, this traffic will be forwarded to the rendezvous point and then forwarded down along the tree. Any receiver can subscribe to this tree. In some manner or in some way, there will be multicast delivered. But the whole concept behind of that is it's so-called shared tree, means no specific information for the source, but just a group, and that is it. Quite important, it's a rendezvous point. Once again, you should have it, and you will have it. I'm really re-emphasizing on that fact because of the following. Within the TRM, or the Tenant Routed Multicast, that is one of those requirements which you need to follow. Nevertheless, another thing you're going to see and you're going to hear a lot today, that's so-called shortest path, or sometimes we can abbreviate it to the PIM-SM. That is where each particular source will be delivering traffic for the group, and basically in that case, there is no need for the rendezvous point as such. The traffic will be delivered or forwarded in a very optimal way. That's more or less it. Now, talking about the multicast, we should never forget one important thing, it's a signaling. So before we have a tree, which can be used to deliver this multicast traffic, we have to build this tree. It does not really exist at the beginning, but it has to be created. And one thing is the fact your tree signaling happens in the reverse direction. What I mean by saying that, well, you can think it's like a general rule for you. Your forwarding is always connection-oriented, which means receiver must somehow inform sender that he would like to get this traffic. As soon as that's accomplished, done, and as soon as you have properly populated entries or within the mRoute table, multicast routing table, then and only then your multicast flow will go. Not before, but only after. For this signaling to happen, we do have two, well, generally speaking, we do have two protocols. One of them is so-called host signaling, or IGMP, Internet Group Management Protocol, and the other, that's a PIM. For the IGMP, just a very short recap, we do have three versions, in fact. The common one is the version 2. Version 3, of course, we see a lot, but it's more specific for the SSM and not necessarily that is something you're going to see right immediately, but version 2 is, is your bread and butter. How it works, of course, I'm not going to go over all details, but just a couple of them saying that whenever host is about to join flow or join multicast feed, if you like, this host supposed to send report saying that I would like to join particular group. As you can see here, IGMP star comma G is in use, which means we don't care about the source, but we do care about the flow. That is it. When that's done, last hop router, well, it's called last purely because you do have receiver behind and sender somewhere else. So this last hop router will create some particular set of entries associated with this multicast saying that we do have receiver there. And presumably snooping in place, we will handle those entries by periodically refreshing the IGMP snooping table. We do that by sending the queries or so-called general queries, which is supposed to be replied by one of the hosts who has particular interest in the multicast. Normally, when host is about to leave, it will also be sending leave group message. It's going to be group specific though, and on this group specific message, we still need to reply somehow by the group specific query saying like, do we still have anyone else here? If we do, then we are good to continue multicast forwarding. Otherwise, we are trying to, the last hop router basically will leave or prune itself from the tree potentially. It depends, but that's the simplest way to explain it. That was in 2 words about the IGMP, but the IGMP is just a part of the game because we still have PIM. And this PIM, that's the really one protocol which is going to be used within Underlay, but not Overlay anymore. Overlay fully relies on the BGP or MP-BGP, to keep it simple. Now, those protocols, well, of course, we don't have time to go over the PIM-SM, but on a Cisco Live page, there are quite some number of very good sessions about the basic multicast. So whenever you need to go there and just check it out, you will be enjoying it, definitely. And here, though, I would like to put a couple of things together, saying that signaling will now look in the next way. We have a host. We have a rendezvous point, assuming that it's a PIM-SM. This host is about to send IGMP join. Upon receiving this IGMP join, router will create a snooping entry, will create a *G entry, and will send the PIM join request to the rendezvous point. That is what you're gonna see there. Now, theoretically speaking, since that moment, you may already start receiving multicast, but we actually never talk about what is going to happen with what should happen basically with the multicast source. Well, there is a special registering process, and this registering process starts with the putting all together multicast and unicast. What I mean by saying that, well, it's kind of very simple. Whenever a multicast feed is there on the router A, which is going to be first hop router in our case, we're going to create 2 entries in the mRouting table, as you can see here. That's going to be your *G and the SG. And then your first hop router will simply encapsulate this packet and send it in a unicast manner to the rendezvous point. That is called registering. When this registering happens, and the goal behind just to notify rendezvous point about the fact that there is a sender, the rendezvous point normally should stop that by sending register stop message. Well, since that moment, we will be, depending on the scenario, we will be trying to build a tree or source-specific tree towards the first hop router, and so on and so forth. But I hope that was enough to kind of warm up you a bit with the information about the multicast. Now, that was the classical one, and you really have to remember a couple of things. No matter what happens with the multicast network, normally your troubleshooting scenario starts with the signaling. You need to know how the signaling was going. You need to know probably where was your rendezvous point, and so on. And based on this information, you will be able to kind of put all pieces of that puzzle together. When it comes, though, to the Tenant Routed Multicast within the VXLAN fabric, well, there were a couple of stages. There were a couple of iterations how we tried to introduce multicast supportability within the environment. And the one was, well, the very first was the scenario where we had nothing, literally. There was no routing, multicast routing as such. There was no snooping. There was absolutely nothing. And that's part of our traditional overlay, traditional multicast forwarding section. So here we are. With no snooping, apparently, we consider everything as a flood, which means whenever we have a source on the left side of our screen, the traffic from this source will be flooded within the VLAN here. Then it is going to be sent over the fabric as the BUM traffic. BUM abbreviation stands for the broadcast unknown unicast and a multicast. And after that, each VTAP or leaf will decap this multicast and send it to the VLAN. Now, beauty of this approach, well, it's very simple. You don't have to do anything literally. But of course, realistically, any host will have and will suffer if you put a lot of unnecessary multicast on it, or the broadcast, or whatever it is. So we were trying to avoid this sort of flooding in any possible way. And the first iteration, the first attempt to do that was so-called VXLAN IGMP snooping. Now, you can already imagine what I'm going to be talking about here. Nothing but just snooping or tracking the receivers. And that's what you're going to have. The leaf 1, or the VTAP number 101 on the left side of the screen, will be forwarding traffic only to the receivers who shown interest, no one else. What is going to happen within the fabric? Well, still, we will be forwarding one copy of the packet over the fabric as L2VNI, and only VTAPs where you have registered receivers will send it down to the host. The beauty is that you are not flooding your VLANs, you are not flooding your segments with unnecessary traffic anymore. Well, apparently the negative part is still we really limit it within one single VLAN. Who's going to do routing for us? Because afterwards, multicast, it's not necessarily traffic forwarding within the single VLAN. But think for a second what to do in this particular case. Well, there were one very ugly approach to solve this problem, but it was there, and that's called router on a stick. So this guy is nothing but a router with the VRF lights connected to one of the leaf, so playing the role of the border leaf now at that moment. And responsibility of this router is nothing but to be a distributed forwarder for the multicast. It is not necessarily to have this router as the default gateway, because each and every VTAP or the leaf, if you like, will be gateway for the local segments, but the multicast still to be routed there on the router on a stick. This will look in the next way. So you still have the same approach in the same scenario. Traffic is flooded, but now the router gets it, does job of routing it, and put it back into the fabric. Now, yeah, we achieved what we wanted. We now have the multicast routed, but in what price? It comes with the price of multiple replication. It comes with the price of no flexibility whatsoever. And there are quite some challenges associated with the reverse path forwarding check can be. To get rid of all that, our business unit, together with the development team, they came up with something more elegant. And I would imagine it will take a bit of time for you to, to kind of understand the elegance or the level of the elegance of that, because there are quite some number of details, but the conceptually it's very, very easy. So here we go. The TRM Functional Components section, or the TRM Functional Components, which I'm going to be talking here about, it is really nothing special except just a couple of things. Here we are trying to follow traditional Unicast gateway approach, which means each and every router or the VTAP where you have VRF registered will serve the role of the designated forwarder. Now I will try to say that in a normal way. Each and every router where you have your tenant or the client will do the multicast routing job for you. That's it. Nothing comes with no price, and apparently we have some attributes associated with the TRM functionality. So the one first is the fact that your underlay must have or must be PIM-SM only. There will be a bit of complexity associated with the multicast there, but nothing really hard. Talking about the overlay, though, we're not going to have any more PIM there. We're not going to have any sort of PIM join process or the multicast registering associated with the PIM, but instead we'll use the concept of next generation MVPN. For those of you who ever worked before with the MVPN, well, you'll find a lot of similar things. And by the way, if my memory serves me well, we're going to have even integration in between NGMVPN and MVPN in upcoming releases. So basically, if you do have something like a shared border router, this will be possible to forward multicast in between, literally multicast and multicast fabric and the multicast MPLS. But that's absolutely another story. Here, though, we talk about TRM basic concepts And those concepts are coming with some interesting portfolio. This portfolio includes number of scenarios, number of different possibilities. The few of them listed, but most important. So there will be RP-less and external RP. I'm going to talk about that in a couple of minutes. RP anywhere, we'll have a few words about that, but that is something what stands, well, literally in between RP-less and external RP solutions. On top of that, TRM does support 3 different modes. L2 TRM, which out of the picture because, well, we are aiming for the layer 3 functionality here where the traffic can be routed. Then L2-L3 mixed modes and L3 TRM. Here we're going to be talking about the L3 only, but what is L2, L3? Well, it's a scenario for the fabric where you still have first generation Nexus 9000 in place. This being said, we are moving forward, and I hope, at least I see this session in the following way. That's the part where things are getting much more interesting. And I'm going to be talking about distributed Unicast rendezvous point, or RP-less. Well, nowadays that's a kind of recommended approach, and that approach, generally speaking, following the same idea of distributed gateway. Each and every VTAP will play a role of the rendezvous point now. So what should you do? From the configuration standpoint, there are not many things, in fact. I'm not going to be talking about this right here, but believe me, there are just literally few extra lines on the code comparing to what you did already and what you did before. The TRM enabling is not a big deal. No matter what is going to happen, but, well, let me put it this way, rephrase it a bit. Whenever you go with the multicast, with the TRM solution, when you enable the multicast on the device, I use this wait word, but in reality it means, you just put a couple of commands there. Your gear will join to the Underlay Multicast distribution tree. And that will be done for the layer 3 VNI group. That's quite important. So what you're going to see, if you do just a show a PM route, you will see that your each and every leaf joined the tree as the source, which means any of them will possibly forward traffic, well, can forward multicast traffic within the MDT. Now, just one side note, and could be useful, I think, layer 3 VNI multicast group should be different from the layer 2 VNI multicast group. That being said, we're moving forward. At this point, there are not so many, interesting and complicated things. But that is why, by the way, I call it as a step 0. We don't really need to care about that very much. Yeah. The next one is apparently a scenario where the source is jumping, where the source is there. So your multicast source is about to send traffic. What is going to happen? Well, we create SG entry. And after that, there should be a way to signal to inform anyone else that we have potential source of the traffic. We do that by making next generation multicast VPN, or so-called MP-BGP MVPN route, which is route type 5, where we say that we have an active source, and this active source is streaming into this group. That is so-called SAAD entry. It's a BGP update which will be forwarded to each and every VTAP. And in that manner, each and every VTAP there is aware about the source of the multicast. Now, the next logical step is the receiver. So receiver, we're jumping here. receiver is about to join. In a classical manner, IGMP join is there. IGMP join is enough to create, in that case, SG entry where the output interface is the host-facing SVI, and the ingress interface is your VRF layer 3 VNI. But is it enough to start forwarding multicast traffic? Well, not really. You need to accomplish signaling. You still need to build a tree. Because if you remember, the leaf 101, which is on the left side, the one where you have a source, this leaf is not aware about where to send this multicast. So the multicast effectively dropped there at that moment. So what is going to happen? We're constructing here MVPN route type 7, or so-called source tree join update. And this source tree join is saying, like, I would like to get this traffic from this source. It's going to be sent directly to the leaf. And at that moment, your leaf is able to change output interface list by saying, yeah, I do have one particular receiver. Now, should we have any local receiver joined here, that's not going to be an issue as well, because you will simply update your mRoute table with the SVI where the local receiver is located. Now, with all that in mind and with all that in place, how then your multicast feed or multicast data forwarding tree will look like? Like in a previous case, you do have a source. This traffic sent over the fabric as layer 3 VNI. Then it is replicated to each and every VTAP, and the VTAP where you have receiver, you have that traffic decapsulated and sent to the receiver. The beauty of that approach is no matter what is going to happen, no matter how many receivers, and no matter in which VLAN we do have this receiver, assuming that they belong to the same tenant, you will have only one single copy of the packet in the fabric. That is it. Now, to make picture more full and more accurate, here is what we're going to have from a perspective of the data packet. The data packet at the beginning will look in a very simple way. We have a source IP. Well, that's your source IP address. Destination, it's a group IP address. Then the packet, when it's forwarded within the VXLAN EVPN, will look in the next way. Here, as you can see, the destination IP of the outer header will be default group for the MDT or the layer 3 VNI multicast group. And the VXLAN is going to be your layer 3 VNI label. With all that together, we are simply replicating traffic, and interested receiver will do the rest for us. So basically decapsulating it and forward it to the receiver. One important note, and well, it can be a trap for sure, at least, for one time. When we do when we do multicast forwarding over the VXLAN fabric, we always forward multicast within the layer 3 VNI, which means we're going to be decreasing TTL by 1 on each hop. If you have local sender and receiver within the classical VLAN, then of course there is no TTL decrementing. Yeah? But if that is over fabric, there will be TTL -1. Just bear in mind. That was it. Was it hard? Well, maybe if you heard about this very first time, yeah, that's a bit too many details. But if practically speaking, the signaling here is very simple. We have a source who is saying, hey, I'm the source, and we have a receiver which is telling us that I would like to get the traffic from this particular source. Two types of messages. MP-BGP MVPN type 5, and type 7. That is it. World, of course, is not ideal, and we always should deal with the different scenarios, or at least should be ready for the different scenarios. The one of them is well, it could be even the transition phase in between your classical non-multicast fabric to the multicast fabric. It can be just something else, but the idea is this. You may have a scenario where the rendezvous point not spread across each and every VTAP, but external to the fabric. And that is going to be quite complicated, at least at the first glance, but in reality, it just adds one more layer of complexity. So here we are. External rendezvous point is a scenario where you have rendezvous outside of the fabric. You'll get this first, but not, the very first step, which is the step 0 again. As soon as the multicast is there, and as soon as the multicast enabled, your underlay receives PIM join for the layer 3 VNI source 3. Nothing special about that. It's just a classical PIM signaling with the join process and so on. So we simply skip it. Now, what is going to happen after that? Well, your receiver is about to join. And in this particular slide, you see receivers on the right side. The one receiver, which is 21, is the fabric client, or the fabric receiver. The receiver 31, that's external one. And this external one, just for sake of this example, connected directly to the rendezvous point, which of course is not necessary. So when the receivers are there, they will inform last hop routers with the IGMP join messages, which will then create or trigger some mRoute table change. In this particular case, as you can see, we do care at this moment about the VTAP, about the fabric. Our leaf 201 will construct MP-BGP MVPN route type 6, saying that, hey, no matter who you are, but I have receiver there. And this will be shared across each and every VTAP. VTAP where you have a rendezvous point connected will also drop a PIM join for the *G entry. And that PIM join done just to create or the update mRoute table with the leaf-facing interface on the rendezvous point. So at least rendezvous point knows that right now we do have receivers somewhere behind of this interface, somewhere in fabric, if you like. Now, what is going to happen after apparently multicast source? And this multicast source, like in the previous case, unconditionally starts with a multicast. That creates SG entry that triggers constructing of the MP-BGP MVPN route type 5 or NGMVPN type 5, if you like, message saying that, hey guys, I do have one particular source with IP address 10.10.10.11, which is streaming to this group. So that is pretty much like in the previous case. We share it everywhere, and now leaves or the VTAPs where you have receivers like VTAP 201 on the right will construct, like in previous case, type 7 message to join source 3. So saying, that's fine that you have a source, now please join me to this 3. Upon receiving that particular BGP update, the leaf 101, we'll put it in the mroute table by the mean of changing output interface list. Simple? I think so. Now, let's stop here for a moment and try to put all that together. What just happened? Well, there was first sort of message, which is the route type 6, to inform that we have a receiver, and that was done pretty much for the external rendezvous point to be informed. Then we had route type 5 and route type 7, like before, like in our PLS scenario. So we have we're saying that there is a source and we're saying that there is a receiver. That's fine. Now, from a perspective of the multicast tree, it will look this way. Pretty crowded slide, maybe, but here are a couple of things which I'd like you to check. And I'm going to put it here, I think. So this one. OIF null on the leaf 202, which means we're going to have three of that kind. Multicast feed from the source, encapsulated within the layer 3 VNI and sent over the underlay MDT as the 239.10.11, effectively replicated towards each and every VTAP. Then VTAPs with the receivers like 201, where you have output interface list saying that we have a receiver in interest, will do decapsulation. But what about the rendezvous point? At that moment, this arrow here, just to show that we may potentially forward multicast traffic, but there is a gap in between leaf and rendezvous point. So what to do in that case? And that's quite interesting because that is, well, sort of solution which stands, in between the classical VXLAN and some sort of knob on top. That is null registering. We're going to construct null register message, encapsulate it into the VXLAN, and send it directly as the Unicast to the rendezvous point. We do that just because we need to create an SG entry on the rendezvous point with the corresponding ingress and egress interfaces there. As a result of that, your rendezvous point will do nothing but literally drop here SG PIM join. And since that moment, you do have only one step left. Your leaf, where the rendezvous point or RP is connected, must construct, again, type 7, saying that I do have a receiver there behind of one of those interfaces. And we'll join this multicast tree by the mean of type 7 message. As a result of all that, you will have nothing but multicast tree, completed multicast tree, and that will look the following way. Isn't it good or nice? Well, I think it is. I mean, I really like it. It does not really talk about the PIM too much, but now it works with the BGP, which may look not very convenient for you at the first glance, and will create some probably difficulties when you try to maintain or to troubleshoot it for the first time. But believe me or not, if you follow very structured approach, that's going to be easy. You just need to know what happens after what. It is not necessarily, well, of course it depends, but it does not necessarily to jump directly to the flow and try to check if the flow is there. Maybe you still need to go one step behind and verify, was there a signaling? or maybe something else was happening. So the idea which I'm trying to put in your heads is the fact that TRM is not so complicated afterwards. Now, this being said, I will give you a chance to think for a few moments on this. What VNI ID, will be used to flood broadcast traffic in TRM? Now, be careful. I'm talking here about the broadcast traffic, not about the multicast. So now all yours. Give it a try and we'll see where are we right now.
Okay, so you might be able to see the answers, Alex, now.
Yeah, I can see the answers. Thanks a lot for really trying, for participating with it. And just a couple of words about the answer. For those of you who answered the BAM VNI, well, that was good attempt, good try, I can tell you. But fortunately for all of us, we don't have such an entity as a BAM VNI. We really talk here about the L2 VNI, and here is why. In a normal case, BAM, which is the broadcast unknown unicast and the multicast, served by the layer 2 VNI. But when the TRM is in place, we do multicast with the L3 VNI only. The rest, like a broadcast and unknown unicast, will still be using layer 2 VNI tag. And effectively, that will be on a different underlay MDT. Nevertheless, more information about that you would probably find very soon when the Cisco Live event will take place this summer. And there will be a couple of presentations delivered by our principal engineers, and one of them is going to be myself as well. But that's literally another story. Now, I do have one question which I'd like to really address. I think Mr. Sergio asked about the VPC VTAP and how the multicast behavior. What was the multicast behavior there? Unfortunately, well, due to time, we are not really covering that scenario. But I think one of my colleagues already replied that the idea here. Well, I'm saying that with the VPC, we still have some sort of mechanism, and I like to reemphasize on that, of selecting forwarder called RPF source forwarder. So literally only one of them will be answering that. Now, we are jumping to the last section, and this section I like very much because it really brings a lot of interesting things, and it makes our TRM is extremely, well, if you like, usable. That is the TRM within the multi-site. So a couple of words about that before we move forward. To make our network scalable, to create a separation not only on the underlay level, but on the overlay as well, to add controllability, we introduce the concept of the multi-site. And that concept has the one important piece, which is the BGV. That's the border gateway router. The responsibility of this router is kind of stitching your site within the other sites without exposing information externally, without exposing, let's say, visibility on the other hosts. And that really means whatever happens within the one site will stay there. If you need to forward traffic towards the other site, this will be done through the BGV, where the re-encapsulation takes place, and the more effective, if you like, forwarding goes over the DCI. In a context of the multicast, we do have quite some number of considerations of attributes, and I really want to warn you that we do a lot of developments in this area nowadays. So with each and every software release, we are literally adding something to the TRM multicast supportability within the multi-site. So be sure that you are checking that in advance, okay? The few things I would like to really point your attention on, and that's the fact that within the site, we still have everything same as it was before. In between sites, we rely only on ingress replication or inter-site replication, if you like. So traffic over the DCI link will be replicated in a unicast manner. Well, is it good or bad? Believe me, that's normally much way better than handle the multicast on a DCI where you may not even have control. So this being said, we are moving forward. Now, how the multicast flow will look like here? Well, like in the previous case, whenever we have any receiver within the site, we're starting with the left side, left bottom, there will be source receiver, there will be signaling like I described before, route type 5, route type 7, and the multicast tree is there. But if we have receiver in the other side, the traffic will be lending BGV, virtual address, BGV virtual IP, and then decapsulated. So we are changing the source and destination IP addresses, sending it directly to the BGV of the other side, and then the BGV of the side 2 on the right will decapsulate it and send it down. Now, to have that in place, we really must follow the next approach. There will be separate signaling between border gateways and within each and every site. Now, here we go. We have a receiver which, in this case, we start with the multicast source. Yeah. So we have a source, and that triggers nothing but the route type message. Route type says, here is the source, and please join if you like. Nothing else. Be advised that this type 5 will be delivered everywhere and on BGV as well, the border gateway on the left and on the right. Those border gateways will reconstruct, not just forward, but will reconstruct type 5 message saying that we have a source for this group. Now, the source address in this BGV will be the BGV itself. The source IP of the outer header as the destination IP of the outer header will be really replaced with the BGV addresses without going any further details. Upon receiving that type 5 update on the site 2, we will do this reconstruction one more time to inform each and every VTAP. So idea here to keep it simple, like the next hop of the traffic, well, general idea if you like, will be always over the BGV. So we're trying to hide what is behind of the border gateways. Now, this being said, we have receiver, and receiver like in the previous case, that's IGMP join followed by the type 7 message. And the type 7 BGP update will be forwarded to the BGV where those BGV reconstructed, send it to the site where there are receivers and nothing but just reconstructing, sending to the first hop router. As a result of that, we have updated routing tables, routing tables, better to say this way, and now we are able to build multicast tree. We are able to start sending this multicast like before. Single copy of the multicast within the layer 3 VNI will be forwarded across each and every VTF. Well, it will be forwarded towards each and every VTF where we have registered VRF and the BGV as well. Then BGV will replicate this multicast feed to the site which expressed the interest. Quite important to mention that both BGV are receiving the stream from the inner side, but only one will be forwarding to the outside world, if you like, to the other side. And this responsibility comes with something called forwarding election. Better to rephrase it. That's a designated forwarder. Sorry, yeah. So this guy is the one who will be forwarding multicast for this particular group, and there will be some sort of load balancing in place. Quite important note, though, the designated forwarding election happens automatically and relies on a special type of BGP update. So if, because of whatever reason, the BGP updates are not flying in between the border gateway routers within the same site, you may get into troubles with that. But that's another story. I'm not going to be talking too much about that. So the idea is only one BGV forwarding multicast towards site which expressed interest. This will be done in a unicast manner because it's an ingress replication. And the IP address of the destination will be the virtual IP address of the BGV where the receiver is located, which means any of them can get this multicast traffic. And that is really handled, again, by the designated forwarder. Okay? Moving forward, with the multicast, when it's there on the gateway, we are really ending up with this sort of, of traffic, if you like. The multicast will be encapsulated with the outer header where the source and the destination are virtual IP addresses of the gateways. That is it. For now, we do not support TRM in BGV with VPC. This supportability should come with the next release, I think, or the release after, like a 9.3.5 or 9.3.6. But that's another story. For time being, there is no VPC in between. When the traffic is getting there, we just re-encapsulating it because we would need to change the destination, source and destination IP addresses. And here's what you get. Destination IP address is going to be your group address. That's a layer 3 VNI group address. The VXLAN tag is always layer 3 VNI. And in that manner, you have traffic efficiently distributed over two sites or whatever, how many sites you have. Couple of words about that. There is, of course, good chance that you're going to have some external domain where the multicast should be going as well. That is also possible to do. In this slide, you see that external layer 3 domain connected to the VTAP. It's not a limitation anymore. In fact, starting from 9.3.3 version, you can have external layer 3 connected to the BGV. So basically, your BGV or the border gateways will play a role of the border leaves same time. And as I said before, and I will just repeat that one more time, more to come. So with all that in mind, I tried to really make it as easy as possible. I didn't go into details about the particular configuration lines, and I never touched the ideas of the troubleshooting, but I wanted to show you the concept behind. And this concept, as you may think at the first, looks very tough, but in reality, it is very, very logical. And this logical flow should be always in your head when you do the implementation or troubleshooting. Now, this being said, there is a last polling question I have to you, and that's nothing but just to verify, if you're still with us or not really. So the question is, what BGP role is helping to avoid multicast replication, or better to say multicast duplication between the fabrics in multi-site network? Now I have a result. Perfect. And I see, well, relative numbers are really good. Absolute maybe not exactly what I was expecting, but relative numbers are really good. So we have a right answer, and this was designated forwarder. Now, about the designated forwarder once more. This is the router where you're going to be handling the multicast. And that's the one who will be forwarding traffic over the DCI link. And by the way, you really need to be careful with that, because the traffic handling, the multicast, if you like, handling relies on a special kind of the access list which you don't see normally, and it's going to be simply programmed for you in the background on the fabric DCI links. So if you do have some sort of troubles with the election, or you improperly or incorrectly assign the labels on the interfaces, that may create some troubles. This being said, I think we get to the point where I want to say thank you for joining, and that is it.
Thank you so much, Alex. It has been a great presentation. As you just have mentioned, it's not easy to manage this kind of topic. It's actually not many people, they are very familiarized. But we really appreciate not only your effort, but also Nikolai's and Aleksandra's effort to helping out to cover the questions, and to the whole team that makes this possible. And of course, to the audience that is with us, because without you, these events could not be possible. We know these are very uncertain times, but you have done a great being with us today. So, Alex, what I'm going to do right now is I'm going to read aloud some of the questions that the audience has provided for you. And before I start to do that, for those who cannot stay with us longer, you can see the recording of this presentation in the coming days, just in the same page where you register for this event at the Cisco Community. That's where we're going to place the video. Also, the slides are already available, and we will place everything together in the same one. So, well, let's get started, Aleksandr. I just assigned to you a question. It says like this: in case of any cast border getaway, is PIP used for boom traffic?
Okay. So the answer is this. For the multicast, for the TRM, to make the traffic forwarding more efficient, we are going to rely on the VIP, on the virtual IP address. That's pretty much exactly what you saw in the slides a couple of moments before. When we are forwarding it towards, literally towards the one of those two BGP border gateways. And the one of them, well, who's receiving it, based on the hashing, because it's just a single packet, will do the decapsulation and will do the rest of the job. That's pretty much the idea behind it.
All right. I have another question. You won't find it on the Q&A, but it says like this: is any cable using DRM on mixed mode with the first generation of the 9000 of Leaf?
Uh, any caveats using TRM mixed mode with the first gen? Well, the best way to the best way to answer that will be, take it as an opportunity to upgrade to next generation Nexus 9000 and not to have the mixed mode. But the answer is going to be very, it's really not easy to answer that in a simply one sentence, because that comes with the complexity, and I'm not sure if we do even support that within the multi-site, but normally I cannot really say anything special about the caveats, but it's just slightly different way and slightly different signaling on that. I can tell you for sure that this, actually I'm not sure if that is going to be covered by my colleague within the upcoming Cisco Live session, but yeah, the answer is going to be this. I'm not aware about any very special caveats, but it's just a slightly different configuration approach and a slightly different signaling. That's the way I would answer that. And if you need to know more, well, better to try to handle that over the separate channels. Maybe have kind of more specific questions after reviewing the configuration guide, and then we can go in a more details. Generally, it works.
Awesome. Okay, thank you so much for that. And I'm going to read like one last question, and it says, how does it work in the case of ACI, like everything you have been mentioning?
Well, that is the question which I believe I would put aside for a time being, because I don't really want to create negative impression or deliver such a wrong message that it works in a different way or whatever. What we can try to do, if this question will be posted in the group, we can try to pull out some information for reading. That's pretty much my answer. I would really like to skip this question and put it aside, because it requires a bit of preparation before I can say.
All right, so what I'm going to do is I'm going to place this question on the Ask Me Anything forum event, so we can validate more information and provide like better details, okay?
That is absolutely fine with me.
Awesome. So then this is as long as we are going to go with this session. Oh, hold on. I think there's, let's just say thank you. Okay, so this is enough for today. I would like to thank once again to you, Alex, Aleksandr, and Nikolai for helping out to make this event possible. It's great to collaborate with you, and to everyone who has joined to this event, and we hope to see you next time. And don't forget just this question that we're going to clarify, and any other ones that you might appear or compare with, we're going to find them there just on the Ask Me Anything event, available till next Friday, May 29. And well, for all of you, just to complete this one, don't forget that the video is going to be available in the couple of days, maybe today, but most likely tomorrow. And you can also find more information about events like this and any other ones, and activities and information related to COVID-19 and Cisco on Twitter, on Facebook. We're also available on Twitter, on LinkedIn. For all those customers and partners that you use the technical app from Cisco, you also can find the community and its content just right there, as well as in cisco.com. And well, if you're looking for FortiIT, like other events like this one, and you speak a different language rather than English, you can find different events available in French, Spanish, Portuguese, Chinese, Japanese, and Russian. So feel free just to join to any of those events and learn in your local language. And well, what I was trying to mention before is just like if you're looking for FortiIT training, you can also have a look to the Cisco Learning Network. They also are providing lots of training if you want to enhance more your career. And once again, well, thank you so much for your time. We would like to invite you to please take a moment to complete the survey. You're going to receive a very quick survey about how we're doing, how did you rate us, and also, and above everything else, what kind of topics would you like to see in future events? Let us know how we are doing and what would you like to see so we can provide great things for you. Finally, for those who fill out the survey, you will be able to redeem a 35% discount on any ebook, any learning title, any video learning material that is available on Cisco Press, like any of the ones that you can see right here. How about getting a 35% discount? Well, by filling out the survey, you can get that one. If you have any issues with that, please don't hesitate to contact me. I'm the host of this event, so you will find my information just right there. And once again, thank you so much for joining today. Good evening, good afternoon, good morning. And once again, thank you, Aleksandr, Alex, and Nikolai.
Thank you so very much, guys, and we'll see you next time then.
Awesome. Thank you. See you.